So myself, Kumar Avelan, the speaker of today. Can I know to whom I have to address? Whether who is the anchor person?
Yes, sir. Yes, sir. Sir, please wait.
Okay. Can I know? Can I know your name, sir? Please.
No, I am Kumar, coordinator.
Okay, sir. Okay,
The
Kumar, sir.
anchor will come at 10 o'clock. She will start.
Okay, sir. I will be in the
Okay,
waiting.
okay.
Okay,
Okay, sir. Okay, sir. Okay.
thank you, Kumar, sir.
Okay, sir. Thank you. Good morning to all. We will start session by sharp 10 o'clock. Okay. All of you mute your mics. Uh, Still, I am hearing some sounds. All of you, please mute your mics. All of you listen. I will share the PPTs and recordings of the videos at the end of the session. If I share now, again you will ask at the end of the session. So at the end of the session, I will share all the PPTs, and if you need, I will give the recorded videos URL also. Okay, we will upload in YouTube and we'll give the URL. Don't send the requests regarding the PPTs and recorded videos. We will share it definitely all together once. All PPTs together once. We'll share it. If anybody have a signal problem, we will give a live streaming link also in the group, WhatsApp group. If you have any signal problems, you can watch live stream also.
A very warm good morning to everyone. I welcome you all to the third day of the FDP series on data sciences, sponsored by AICTE Training and Learning Academy and organized by Department of Computer Science, Central University of Kerala. Today we have Dr. G. Kumaravelan sir, Assistant Professor, Department of Computer Science and Head of the Department in charge of School of Engineering and Technology, Pondicherry University. Dr. G. Kumaravelan sir has published more than 25 research papers and he is a very expert in the area of data sciences, human-computer interaction, machine learning and theory of computation, etc. And he has presented a number of his research works in different international and national conferences, and he received 2 Best Paper Awards in international conferences organized by IITs, and he has received Best Teacher Award by Pondicherry University based on students' evaluation continuously for the past 6 years, and he has 14 years of teaching experience and 4 years of research experience. So today we have got a very eminent personality from the field of data sciences to handle the topic on mathematical foundations for data sciences. On behalf of the Department of Computer Science, I heartily welcome you, sir, to this FDP series.
Thank you, madam.
I request you to start with your session now. Off to you, sir.
Thank you very much for the nice introduction, madam.
Thank
I think you got all these details from my website. Okay,
yes,
is it
sir,
so?
yes, sir. Yes, sir.
Okay, thank you, madam. So can I present my screen, sir, right now?
Yes, yes.
Yes, sir, you can start now.
Sir, are you able to see my screen, sir?
Yeah. Yes, sir, visible. Continue.
Okay. So after an introduction of myself, so Kumaravelan, Assistant Professor, Head in Charge, Department of Computer Science, School of Engineering and Technology, Pondicherry University, Karaikal campus. That is missed. That's why I repeated. So my topic today is given to me by Kumar sir is mathematical foundations for data science. So I think I'm standing in the third day of this program with respect to data science.
Yes, sir, yes.
Yes. So if you're having any queries, dear, you can ask me last, right? So that it is very easy for me to complete all the details because it's a vast content is given to me, right? So that is linear algebra, statistics, probability, and hypothesis testing. So each takes its own time, right? But I try to complete all these concepts, right? If you are active and at the same time, if you give me some room, right, without any kind of disturbance in the sense, some noises, okay, I think you will cooperate with me. Straight away, I'm coming to my business, right? So this is my outline of my presentation. So even though the past 2 days, you heard about some introduction about the data sciences, right? So my friend Surendran talked about some tools related to data sciences. And at the same time, you come across with some deep learning techniques also. But here I'm not going to do any kind of things related to machine learning or deep learning. But whatever may be the mathematics behind all these kind of stuffs, right, that I'm going to touch upon, right? So before going to see all these mathematics, you have to know some fundamental mathematics, right? For all, which is something more essential for linear algebra, statistics, probability, and hypothesis testing. So that thing I am going to cover for from 10 to 15 minutes. Later, I will come to my actual area. So before that, right, I want to talk about some 5 minutes related to introduction about data science. So just a question, right? I'm not going to depth, right? So why data science, right? Because data is all around, right? Lot of data is being collected and warehoused. That is the purpose we are moving to this particular field of research, right? So if you see enormous amount of data is there, e-commerce data is, financial transaction data is there, bank data is there, right? There are several ways in which you can get the data. That is the purpose. If there is no need, if there is no data, then it is obviously it's not necessary to discover any knowledge. So that is, we are going for data science. Next, what type of data we are having? So if I ask this question, the types of data to a mathematician, he will say a data can be classified into discrete or continuous. If I'm going to ask this question to a physicist, he will say a data may be analog or digital. If I'm going to ask the same question to a social science people, he will say primary data, secondary data, like that. But for computer science field, if I ask this question, I think everyone will know the data may be of three types, right? That is structured, unstructured, and semi-structured, right? So all data science going to be deals with this type of data only. It may be a structured, unstructured, or semi-structured. So a relational data, we will call it as a structured data. So some structure is there. The data which is organized in terms of rows and columns, I can say that is a relational data. If the data is of free form, that is called as unstructured data. I will call it as a textual data. Apart from that, there is one semi-structured data, which is a combination of text as well as that is a structured and unstructured, right? Apart from that, you come across with graphical data, social data, and streaming data also. For whatever may be the data, it can be fit into these three groups: structured, unstructured, semi-structured. So in data science, you can't do anything with unstructured data or semi-structured data. So you have to convert all these unstructured and semi-structured data to structured one, right? Then only you can do all the functionalities. So there comes mathematics, right? How to convert this unstructured data to structured one. And even if the data is in the structured version, how to do some processing, right? So I think you people in this program, you come across with several algorithms, right? And tool to implement all these algorithms. For everything, there is a mathematics, right? Without this mathematics, the tool never comes. The packages in any particular programming language doesn't span. So such an importance is there for mathematics, right? That is the thing I'm going to cover, right? I'm going to touch upon with some basic things, and finally I will correlate all the concept that I have discussed with a real-time examples, right? So I think, I don't know whether I will complete all these stuffs within 90 minutes, but I will do my level best. Okay, finally we are having a data, structured, unstructured, or semi-structured. What we are going to do with this data? So for the past 2 decades, we are doing aggregations and we did some statistics. And at the same time, if the data is there, we are going for searching and indexing and querying, right? Now only this field of data science, we are in the stage to discover knowledge, right? So the terminology that I'm going to right now coin is a data mining. This is not a new topic, right? In 2000 itself, I think it's came around the computer science terminologies, right? So right now we are calling it as a data science. In data science, we are saying it is a machine learning, deep learning. All this comes under the umbrella of AI, right? I don't want to discuss all these things because I think in past 2 days we come across with these things, right? And in the next 2 days also you are going to discuss about all these knowledge discovery procedures, right? With respect to machine learning and deep learning, right? Okay, with this assumption, right, I'm defining what is data science. According to my perspective, I can say it's a theory and techniques from many fields. It's not only computer science. I can take some concepts from physics. I can take it from mathematics, applied mathematics, statistics, right? For what? For making, to whom I have to do all these things? For the decision makers in any particular application. Either it may be engineering, economics, politics, or finance and education. There are n number of fields out there. So in this way, I can define data science. Okay, the most important question, again, I'm coming to why it is so popular nowadays. If I'm going to ask this question, say for example, if you see in this pandemic period, there are a lot of webinars are going. So if you see on an average, so most of the seminar, it is my probability, right? It's uncertainty things I'm giving the answer. Most of them, right, are related to data science. Right? Why is it so popular? See, if you ask any people, they will say, yes, I'm working on data science like that, right? So why it is so popular? If I want to give the answer to this particular question, surely I think you people know this particular thing called Garnet hype cycle, right? So please, I request all the participants to see the various Garnet hype cycle that is released with respect to emerging technologies from 2014 onwards. If you see that Garnet hype cycle, you will find this technology, data science, right? Still, right? I think still for another 5 years or 10 years period, surely data science will be there, right? Okay, so the things that I have given at the bottom, right? You're seeing, here, innovation trigger, peak of inflated expression, thought of dissolution. So these are all the various things are there in specifying the Garnet hype cycle. I request all the participants to know about Garnet hype cycle. And being a computer science professional, and if you want to choose any particular technology, please look into that, right? Surely you will see the popularity of that particular thing. Okay, so that's all about some introduction. I timely finished this introduction about data science within 10 minutes. So that is, I think I'm going with my objectives. Now I'm coming to my area, right? So if you really want to do some good things in data science, you have to concentrate on these particular areas. Mathematics, surely. I think most of the data science people will never give more importance to mathematics, applied mathematics, statistics like that, right? They will give more focus towards one particular programming skill. Either I think it may be an R, it may be a Python, right? I think how many of you don't know Julia, right? And I think most of you know structured query language, right? So still there is a competition. If you want to be a professional in data science, whether I have to gain some programming skill in R or Python, right? Each has its own features, dear participants, right? You can also integrate R in Python and Python in R, right? Okay, so whatever may be the functionalities in data science you are going to learn, that can be available in packages in both R and Python, right? I think you are going in this workshop, you are going to have some kind of a hands-on in Python or all, I don't know. But anyhow, right? So here my focus is towards mathematics, applied mathematics and statistics, right? So the remaining things, machine learning and deep learning, I think you will get all these stuff from other resource person. My friend Venkateshan is there tomorrow, right? He's going to he's going to entertain you for the entire day, right? Please, but surely you will come across with so many mathematics over there, right? So now I am going to touch upon all these basic mathematics and applied mathematics to enhance your skill with respect to machine learning and deep learning in the field of data science. Okay, I am coming to my business. So now I am going to touch upon some mathematical, whether I'm audible?
Sir,
anyone?
Yes, yes, audible, sir, audible. Continue.
Thank you.
Yes, sir, audible.
Whether my language is okay?
Okay, sir, okay.
Excellent,
Continue.
sir. Excellent.
Are you able to follow me?
Yes, sir.
Yes,
With
with
the
this
help of the PPTs, actually. No
okay.
issue.
Okay. See, if it is a mathematics, I have to use boards to solve problems, to prove theorems, right? I think it will take too much of time, so that I can make everything in terms of PPTs, right? So surely at the end of the session, I will give this PPT to your coordinator. You will make use of it, okay? And surely it will be useful to you, all right? Okay, now I'm coming to my business. So this is a basic mathematics that I'm going to touch upon, right? So in data science, the most important thing is data set, right? So a data set can be populated with data. So if you want to know the meaning of the data, you have to know the function, you have to know the mathematics set theory and function, right? That is the thing I'm going to touch upon for another 10 minutes of time. What is a set? A set is basically an unordered collection of objects. That objects may be structured one, unstructured one, or semi-structured one. So this is a general definition of a set. Okay. So that set can be represented mathematically in two ways. One is by roster method or by set builder method. See here in the example, I'm describing the description of a set by listing the elements within the braces. That is an example of roster method. See here, I defined a set named V, which consists of 5 elements, A, E, I, O, U, right? I think now you understand the concept of how to define the set using roster method. I think we come across with this mathematics in 10th standard onwards. So the next is set builder notation, right? So this is the another way of representing the set. right? See, this is the method in which if you see any standard journals, right, if they want to describe anything mathematically, they will go for this set builder method only for defining the data, right? Okay, see, here I defined a set named X, A, right, which consists of element X such that the X comes from the set S with the property P of X. Okay, that is, A is a set of all elements X of S such that X satisfies, that is all the element of X which satisfy the property P. Okay, I'm giving, here is an example. See here. If X equal to 2, 4, 6, 8, 9, this is a roster method of listing the elements, right? So if I want to represent in set builder notations, let us see here, this is the way I represented. See, X is a set which consists of elements N. N comes from where? N comes from Z. I think how many of you know what is Z? So you have to know, dear, as a computer science people, you have to know certain notation for all the numbers, right? So here Z is integer, right? If you see that N, the property is given here. This is P of X. So the P of X is what? So whatever may be the elements N, it should be even. And at the same time, the N should lies between 2 to 10. That is a property. I think now you understand what is it, how to represent the set, right? Through Roser method and set builder method. So these are, I said that, you know, several notations are there for numbers, because ultimately in data science, you are going to populate the data set with some numbers, right? It's a continuous data. There is also possibility to have the categorical data. So while representing the data in a categorical fashion, I think this thing will not be used. But if the data are continuous in nature, you have to be very cautious, right, in representing mathematically. So N, you know, natural number, Z, integer, Z plus, Z star, E, Q, Q star, Q plus R, R star, R plus C, and C star. So since it's a theory, I will give the PPT to you. You can get all these things here, right? Because I don't want to waste my time over here. Yes. Next, I'm coming to the concept of subset, right? So suppose S and T are the sets. If every element of T is also in the element of S, then we will say T is a subset of S, right? This is a symbol which is used to represent the subset of S. Straight away, I'm coming to an example. See here, I'm seeing I have given the set X, set Y, and set Z. I'm saying Y is a subset of X because all the element of Y, A, I, U, belongs to Z. So that I'm saying Y is a subset of X. Then I'm saying Y is a not subset of Z. Why I'm saying? Because there is an element A in Y which is not in Z. So that I'm saying it's a very, very important here. While defining in data science in a data set, one attribute depends upon the other attributes. Collinearity will come, right? There comes subset theory, right? That's why I stated this one. And next is set equality, right? So if you want to say two sets are equal, right? So if you establish this particular property, say for example, if you want to establish the two set X and Y to be equal, if you are going to do X, then automatically it implies that X and Y are equal, right? Say for example, again I'm correlating with data science. You are populated, the data set is there. It consists of several features, right? If one feature is totally dependent on the other feature is totally dependent on the previous one, then there is a not necessity to have that particular feature in your data set, right? Redundancy comes, right? So there comes set equality will be more useful to you. Next, I'm coming to finite and infinite state. Simply saying, when the number of elements in the sets of finite, that is countable, then it is called finite set. If the number of elements in the sets are not countable, then I can say it's an infinite set, right? Okay, fine. See here I have given examples. Y is a finite because the finite element of sets are there in Y. P is a finite set. See here E is an even in all even integer. It's not possible for me to count all the elements, right? So that I'm calling it as an infinite set. Again, I am given some related to empty set. Phi is an empty set, which consists of 0 element. Okay, fine. The cardinality of set, it's a very, very important thing for solving many real world problems, right? See, if the data set is there, they will ask you the size of the data set. But the size of the data set comes from the cardinality of the sets only here. That is, counting the number of elements in a set is called cardinality. It is represented mathematically by means of this operator. See here, I'm having a set P and I'm determining the cardinality of P, that is 3. Okay. And the another most important thing is power set, right? When a set is given, writing down all the possible subsets, it is called power set, right? It's having a very, very vital role in real world applications. If you want to narrate the possible ways in which I can solve the problems, there comes power set. See here, there is a set X, which consists of elements red, blue, and yellow. See, what are all the possible ways in which I can arrange these elements, right? So it's a 2 power n. It's a very nice formula, right? So here 3 elements are there, 2 power 3, 2 power 3 is 8. So these are all the various possibilities in which I can arrange, right? So I think now you understand the power of power set, right? So for writing the possibilities, right, in how many ways I can solve the problem. So there comes, I have to arrange. I have to do a lot of permutations and combinations. It's another thing which is talks about related to combinatorics, right? So that is a different thing here. Okay, now I'm coming to operation. I don't want to waste my time here because you have to know there are some operations on sets. I have to talk about union. I am going to talk about here union, intersection, complement, and difference, right? Okay, right? Okay, fine. Okay, if you want to do some kind of a set operation, you have to know one thing called universal set. That is a set there I can get all the elements in this planet. Okay, okay, and any particular, whether I'm audible?
Yes, sir. Yes,
Thank you,
audible.
thank you, thank you. Because I'm not able to see your things because I slide showed my presentation. That's why. Okay, so every 10 minutes I will ask this question. Sorry for that. Okay, fine. I'm proceeding. I'm proceeding. Some noise is there. Okay, thank you. Thank you.
Sir, we will
inform
if
any disturbance is there.
We can continue.
Sir.
Okay, thank you, sir. Thank you, sir.
Okay.
Okay. Now I'm coming to set operations. So you need see here, union of two sets, right? Union of two sets means I'm going to get the elements of the set 1 and along with the set 2. If there is any duplication or commonalities is there, I have to remove it. Some noise is there. So I kindly request the participant to mute their mics.
Yeah, all of you please or else I will disconnect you from the meeting.
So I kindly
people will be removed from the meeting. I already requested so many times. Please mute your mic.
Can I?
Yes, sir.
Sir, I'm getting some noise.
Yes, sir.
Sir, can I continue? Because I'm continuously getting some noise. I think some participants have not muted their mics.
Sir, it is from the university ID only. It is from this university ID.
University ID. From my side?
I think the disturbance
from the organizer side, sir.
Okay, ma'am. The noise is from the host. Okay. So I request the coordinator to mute their mic. Thank you.
Sir, continue.
Okay, sir. Okay. The union operation, the union of two sets X and Y is denoted by X union Y. It is defined to be X such that the elements of the X should come from the capital X set, or it may be from the set Y. If there is any commonality is there, I have to remove. So this is a pictorial representation of union operation, right? I have to write all the elements of X, and at the same time, I have to write all the elements of Y. See here, I performed a union operation with respect to the set and X and Y, right? So if there is a commonality is there, because phi is there in both sets, I have to return once. It is enough for me. That is the objective of union. Similarly, intersection, I have to write only the common elements. That is the element which is common to both X and Y, right? That is the thing, small x, right? You will see the shaded part. That is called, here in the set X and Y, the common element is phi. That is called intersection. See, this is very, very important in statistics, right? for in defining some addition theorem, multiplication theorem, conditional probability, right? That is intersection, right? Okay, fine. This is a very, very important thing in data set, disjoint set. Say, for example, if you're having a data set and it consists of some 100 features, right? So all features should be distinct. Otherwise, there should be some redundancy. That thing, mathematically, we can say disjoint sets, right? So there is no commonality between the set X and Y. Then that set is called as disjoint sets, right? Actually, if you're going to populate your data set for data science problem, all the features should be distinct. It should be disjoint in nature. Then only you will yield some good result. Right, difference, right? So you can find X minus Y. That is, I'm going to write only the element of X. If there is some elements from Y is there in X, I have to remove it. That is the meaning of what? Difference. See here, I'm going to perform Y minus X. See, if that is, I have to write only the elements of Y. C, D, E, F. But C and D is already in X. So I have to remove it. I have to write the elements E, F only. That is the meaning of difference. Similarly, complement, right? So for doing a complementation of any particular set, you need the elements in the universal set. Then only you can do complementation. That is a general property, right? See here, with an example, I will explain you. C, D, E, F for the elements of X and A, B, C, D, E, F for the elements in U. Then the complement of X, so whatever may be the element which is not in X, but that element must be in U. That is going to be the complement. Z bar, that is A comma B. It's a very, very important operation in data science. If you come across with several machine learning algorithms here. And next is Cartesian product. Again, it plays a very, very vital role in data science by correlating multicollinearity. Right. See, for example, if I'm having two sets, X and Y, right? So I want to find out what are all the various ways in which I can pair the elements of X and Y. That is called Cartesian product, right? See, for example, here I'm having the set X and Y, having the elements A comma B and C comma D. So in what are all the possible ways in which I can correlate, right? Say, for example, if I want to do some association or if I want to do some kind of correlation inside the data. So there it is very, very important. See, here I'm writing AC and AD. Similarly, BC and BD, right? This is for X cross Y, X Cartesian product Y, right? So that's all related to set theory. And if you want to prove certain things, right, mathematically, right? So these are all the various fundamental properties are there, right? Idempotent law, associative law, commutative law, distributive law, complement law, evolution law, dominance law, identity law. The most important is De Morgan's law and distributive law, right? So if you are strong in all this law, you can prove any particular concept in data science with related to set theory. So with this, I am concluding the heading called set theory. Now I'm going to a very, very important, all topics are important here. I'm coming to the topic called function. Say, for example, ultimately in any machine learning algorithm, you come across with optimization theory. So in optimization theory, what you are going to do? You are going to optimize a function only there, right? So if you want to know, if you want to get in-depth mathematical things related to optimization techniques, basically you have to know what is function first of all, how to represent the data through function, how to find the relationship between the data, right? So that for that only I am going to cover this topic for another 5 to 7 minutes, right? Again, I am focusing only on basic mathematics. Later I will move to linear algebra, right, within 5 minutes. Okay, I am defining function. See here, so we can define function when the two sets are given, right? See here, A and B are the two sets. I am defining a function from A to B. That is actually represented mathematically F colon A to B. That is here, this is function. So when I will say it is a function, I will say F to A to B is a function which has an exact assignment of one element of B to each element of E. Then only I can say F is a function. Otherwise, I will not say F is a function. See here, I will say this is a domain and they will call it as a range, right? Say between, I defined a function F between A to B. So if you see all red dots, right, we'll have some mapping. then only I will say it is a function. See, for example, if a red dot having 2 mapping, then surely it will not be considered as a function. Okay, the diagram in the upper part, right? It's a function. The diagram which is in the lower part of the slide is not a function because some elements in A having multiple images. I think now you understand the concept of functions. So these are all the various examples in which you can solve some problems related to functions. See here, I'm having the sets A and B, and the function is defined like this, a mapping. The element 1 is mapped to C, the element 2 is mapped to A, and the element 3 is mapped to C. Whether it's a function or not, yes, it is a function, because all the elements of A is having some kind of an image with respect to B. See, in example 2, so A equal to 1, the same problem. So I defined a function called G. Whether I can call G is a function? No, because if you see, the element 1 has 2 images, C and B. It is not the actual definition. It never falls under the actual definition of function. So I am calling it G is not a function because G is assigned to both. G is assigned to both C and B. Sorry, G of 1 is assigned to both C and B. Right? I think now you understand the meaning of function. Now there are several preliminaries are there in a function. I already said that, you know, domain, codomain, image, pre-image, range, like that. So if I'm going to define a function between the two sets A and B, right, then all the elements of A is called as domain, all the elements of B is called as codomain. Okay, say for example, A and B be the two sets, and I defined a function 1 to C, 2 to A, and 3 to C. Now, what is an image of 1? So, image of 1 is, see, for example, there is a mapping C. So, C is the image of the element 1 in this function F. Similarly, what is a pre-image of A? So, how I got A? From 2 only I got. So, the 2 is the pre-image of A. Similarly, what is a domain of F? So whatever may be the elements from A, it is called domain. See, while framing a data set also, you come across with all these things. You have to know, right? If you want to define in terms of equation, you have to mention domain and the codomain. So what is a codomain of F? See here, B is all the elements of B is called codomain of the function F, A, B, C. And what is a range of F? Range means while doing the mapping, so C, A, C. So that are all the elements, right, which comes in the range of the function F, A and C. So that's all about some terminologies behind any function. Okay. Now I'm coming with different types of functions are there. Injective function, surjective function, and bijective function. So I will put something related to 5 minutes over here, and I will move to linear algebra, which is a very, very essential thing. Okay. Now I am coming to one-to-one function, otherwise it is called as injective function. See, here in the right-hand side of the slide, you are seeing one function F tends to A to B. If you see the domain, all the red dots is mapped to B. Then it is called injective function, one-to-one function. See here, why in the left-hand side a function F tends to A to B, I am not calling it an injective function because, see here, the two elements, right, in A having the image in one particular element in B. So that I'm saying this is not an injective function, right? Okay. So this is an example for that, right? I don't want to waste my time over here in example. I will give the slide to you. You will explore it. And next is surjective function. See, in surjective function, if all the codomain elements are covered, then automatically that mapping is called surjective function. See here, all the elements of in B, right, that is a codomain, is covered with a domain, right? That is called surjective function. Now we come across with the injective function and surjective function. If there is a function which has the property of injective property and surjective property, so surjective function otherwise called as onto function. Otherwise I can say if a function which is one-to-one and onto, then I will call it as bijective function, right? See here, all the elements in A is mapped to B, okay? And there is an exactly one occurrence is there. That's why I am calling it as a bijective function. It holds the property of one-to-one, and at the same time, it holds the property of onto in nature. So that I am calling it as a bijective function. Okay. So another important operation, there are several things are there, but with respect to data science, composition is something more important, right? How one attribute is related to another attribute. If there is any multiple collinearity is there, then automatically I have to remove it. So that thing mathematically I can specify through the operation called composition, right? If there is a mapping from A to B and B to C, it is not necessary to write the set B. I can directly write the features A and C. I'm giving this example related to data science only, right? See, for example, A to B and B to C is there. So it is not necessary to have the feature in B. So I can directly write A to C. That's all. I can now the dimensionality reduction comes into picture, right? In principal component analysis by using the concept called composition, right? With respect to the theory of mathematics function. Okay. Now, so after 35 minutes of talk, I finished basic mathematical foundations, right? Only. Now I am purely coming to the data science, right? Here the business given to me is to give a talk on linear algebra, statistics, probability, and hypothesis testing. So, okay, I'm coming directly to my business is linear algebra, right? I don't know how many of you, right, know this particular mathematics linear algebra. I think we covered this kind of mathematics from 10th standard onwards, right? But it plays a very, very vital role in data science, especially in understanding the structure of the data set. If you really want to understand, if you are really going to frame a primary data set, right, surely you have to know linear algebra. Otherwise, it is not possible for you people or we people to create primary data set. But in computer science, basically, we are all working with benchmark data set. That is a secondary data set, right? But anyhow, someone will create the primary data set, you know. If he or she knows clearly linear algebra, then only that data set is going to be called as a benchmark data set, right? Ultimately, if you say, what is the role of linear algebra in data science? I can say, if you want to visualize it mathematically, the structure of the data set, then with the help of linear algebra, I can do all these things. That's all. So in linear algebra, what are the most important things for data science? You have to know these two things, dear participant. One is matrices, another one is vector spaces. So right now, today, I'm going to talk about, elaborate several concepts behind matrices and very few concepts in vector algebra, right? So again, it would be some preliminary mathematics here, but if you know clearly these preliminary mathematics, then only you can know the under-depth things in data science, especially with respect to principal component analysis, that is dimensionality reduction, which is a very, very important thing in data science, right? Otherwise called as feature reduction, right? Okay. So again, it's I don't want to motivate you, right? Because linear algebra play very, very vital solution to solving the linear equation, right? And with respect to computer vision, I think here how many of the participants doing some research related to image processing, that is computer vision, right? There you need some, you have to know the basics of linear algebra, right? Then machine learning, there are a lot of algorithms are there, especially support vector machine, navy base, right? And at the same time, decision tree algorithm, random forest, XGBoost, PCA, and for if I think tomorrow, today I think evening session NLP, right? They come across with bag of words representation, right? For all these things, you have to know linear algebra clearly. And in tomorrow, day after tomorrow, there are some people they're going to discuss about deep learning, right? So deep learning is a multiple neural network. That's all. Ultimately, what you are going to do, you are going to learn the weights of the future, how to represent the weights. There comes matrices, right? Okay. And finally, regarding in optimization technique also. So if you turn left and right of any particular machine learning algorithm or deep learning algorithm, you come across with some mathematics that is related to linear algebra. So that is the thing I'm going to focus right now. Yes. First, I will take how to solve some problems in linear algebra through some solving some simultaneous equation. Okay, so time is 40 minutes up. Okay, okay, I will go with some basics. Let's start with a simple problem. Suppose that the price of one ball and two bat, two ball and one bat is 100 units. We need to find the price of a ball and a bat. right? It's a well-known problem, simple problem, right? How this problem can be converted into a equation? It's very simple. I can substitute. I want to find the price of ball and bat, right? So I'm naming the ball and bat with a variable x and y. I want to find out that particular price for x and price for y. That's all. This particular problem can be represented mathematically like this. What is the first thing? One ball, right? And two bat. One ball, x, two bat, right? Y. So x plus 2y. How many units? 100 units. That's all. And what is the next problem? Two ball and one bat. That is 2x plus y equal to 100. See, whatever may be the problem, I can easily transform the problem into mathematical form by means of a polynomial. Here it is a linear, right? Why I'm saying it's a linear? Because if you see the degree of any variables, you will find the degree 1. So it's linear in nature, right? Otherwise, if it is more than 2, quadratic, 3 cubic, generally it's a polynomial. Okay, fine. See here, now I want to find the values of x and y. See, by doing some lot of permutation and combinations, I can find several values of x and y, which equates to 100, right? That satisfies this equation 1 and 2, right? So pictorially visualize this, if I want to visualize this problem. So these are all the various points, 50, 10, 100, 0, 100, and 100 by 3, 100 by 3, and 30, 40. So these are all the various points which satisfies this equation 1 there. Okay. Similarly, these are all the points, right? 0, 50, 100, 0, 100 by 3, 100 by 3. These are all the points which satisfies the equation 3. So just because it's a linear equation, draw a line, right? Just draw a line. So whatever may be the line which intersect at the one point, that is the actual roots of these equations, right? So this is the way in which I can visualize this problem. Previously, I stated the problem verbally. I stated this problem verbally, and later I formulated this problem into equation, and I visualize this problem by means of a graph, right? Now, how to solve this problem actually? Right? So here I am going to solve if the number of variables are less. See here in this problem, the number of variables are only 2, and the number of equation is also 2. If it is going to be more, then automatically it is very, very tough for a mathematician. We can visualize only 2-dimensional, 3-dimensional. So above 3-dimension, it's very, very, very difficult to visualize, right? In order to visualize all these things, we are going for the representation called matrix, right? So whatever may be the data set, you are going to do it for your problem domain. Finally, it will be in the form of rows and columns. I will call it as a matrix. Okay. Once the matrix representation of a problem is there, then I can do wonders by using this linear algebra. Okay. Now I'm coming to the one concept called vector space, right? In linear algebra. What is a vector? So generally speaking, a vector in R power n, I already told that R is a real number, right? And n is the size, right? So a vector in R to the power n is a column of n real numbers. These real numbers are called components or entries of the vector. That's the definition of a vector. So it's just like I can say it's a one-dimensional set of elements. I can say like that. Okay. See here, I defined a vector V, which consists of 3 components, -2, 0, 1. So I am saying it's a R power 3. So if you see any IEEE paper, so they represent in terms of equation by using these notations only here. So R power 3 means that is a vector which contains 3 elements. So here in this example, the elements are -2, 0, and 1. Okay, what are the operations that I can do on the vectors? Basically, I can do 2 operations, that is addition and multiplication, right? So the another slide there, I am going to visualize the vector. So I think in your 10th standard mathematics, they usually call a vector is a quantity which has magnitude and direction. See here, the blue line, the green line, I'm calling it as a vector. It has its own magnitude. Magnitudes means the values. Let us consider 0 to 1, 1 to 2, and 2 to 3. That is a magnitude. And the direction in which it moves, that is, it moves from east to west. So it has a direction. Similarly, the vector, the green line, I can call it as a vector. It has its magnitude and the direction. What is the magnitude it has? Say, for example, 0, 1, 1, 2, 3, and 4. It's having the value And similarly, in y-axis, it's having a z 1, 2, 3. So I can say it's a 4, 3, right? 4, 3 is the value, right? Right? And it has its own direction, like this here. So here I can do two operations. Either I can do some addition or I can do some multiplication, right? Okay. So I will explain you the application of vector by taking a real-time data science problem around 11:15 exactly, if time permits, right? I will do some text analytics, right, with respect to this vector operation, right? Now, straight away, I am coming to the concept called matrices. So I think everyone knows a matrices is a way in which I'm going to organize the data in terms of rows and columns. In data science, it is generally used to store information like weights in artificial neural network, that is in deep learning, right? Ultimately, in any machine learning algorithm, you have to do some training and testing the data, right? So the data set can be modeled in terms of matrices. Yes, I can say it's a two-dimensional array of numbers. Here you are seeing a matrix A, right? 3 rows and 3 columns, right? I don't want to go in depth regarding the representation like that. If you want to access the element 5, that is, if I'm going to consider it as a matrix, that is second row and second column, that is I, j. 1, 2, A of 1, 2 means first row, second column, that is 2. Okay, fine. Next, these are all the terms you have to note here, right? To define your data set properly. Order of a matrix, that is number of rows and columns, right? Square matrix, that is when there is a equal, that is a matrix in which the number of rows is equal to the number of columns. Then that kind of data set is going to be a square matrix. So it is always advisable to have a square matrix, right? To do some effective machine learning operations. Diagonal matrix, for solving really the simultaneous equation, you have to make your problem to diagonal matrix. That is a matrix with all non-diagonal elements equal to 0 is called diagonal matrix. Upper diagonal, say for example, in a square matrix with all elements below the diagonals are equal to 0, then it is, I will give some examples. Upper diagonal, upper triangular matrix. Similarly, there is a concept called lower triangle matrix where in square matrix with all elements above the diagonals are said to be equal, then it is called lower triangular matrix. This upper triangular and lower triangular matrix are heavily used in solving simultaneous equation or any characteristics equation, right? So there is a concept called scalar matrix. A scalar matrix with all diagonal elements equal to some constant, it is called scalar, right? Okay, fine. So now identity matrix, it's a very, very important for performing inverse operation. Once if you know the inverse of the matrix, then it is everything is over with respect to data science related with regression, right? So if I know inverse, I can do some regression analysis, yes, mathematically, right? But there are several tools, and right now there are several equations out there. Okay, fine. Identity matrix, everyone know in a square matrix, if all the diagonal elements are equal to 1, then it's called as an identity matrix. Similarly, column matrix, row matrix, a matrix consists of only one column, it is called column matrix. A matrix which consists only one row, it is called row matrix. And trace, it's a sum of all diagonal elements in a square matrix, is called trace. So if you know all these things, then you can clearly categorize your data set, right? Now, I don't want to waste my much time over here in matrix arithmetic here. You can do, I think, matrix addition, right? You come across in your, I can from schooling onwards, right? So I don't want to waste my time over here, right? Just you can add the matrix through by means of, but before adding any two matrices, the rows and columns should be equal. That is a very, very important criteria. Okay. Okay. So see here, I will give you a simple thing. So 1 plus 3 is a 4. 0 plus 4, 4. Minus 1, minus 1, 2. Like that. You have to proceed for the remaining rows and columns. Similarly, the most important thing is the product. That is A to B. Because if you want to find the inverse, I have to multiply the matrix with its determinant. Okay. I will come with this concept later. Right. This is the way in which I can do matrix multiplication. Right. So if you want to do multiplication, then you have to know one important thing, right? See here whether the matrix multiplication is possible between A and B. This order of this matrix is 4 by 3. This is 3 by 4. So yes, this row and this column and this row both are same, so that the matrix multiplication is possible. And this is the mathematical way in which I will derive the product AB. That is C11. How I got it C11? That is A11 into B11 plus A12 into B21 plus etc. summation B1k into BK1. That summation value of all these value gives C11, right? I think the assumption that you know this kind of operations. I'm moving to the next slide, right? I already told that if A into B is there, surely B dot A may not be equal, right? This is a basic principle. Okay, I already explained about identity matrix. Okay, transpose matrix. If I'm going to change the row by column and column by row, then it is called transpose matrix. Why I am discussing all these things? Because for doing inverse operation, transpose of a matrix is something more important. So why I have to do some knowledge, why I have to learn inverse matrix? Because in data science, if you want to reduce the redundant features, that inverse operation is something more important. Okay, yes. Now I am going to solve this equation through the concept of inverse, right? Okay, I think already 40 minutes is over. Okay, fine. So representing the equation in matrix form. See here. So this is my equation. Don't say it's a matrix. See, what is the first equation? I can say like this, right? X1, x plus y plus z. Okay, x plus y plus z equal to 1. 2x plus y equal to 4. 5x plus 3y plus 2z equal to 4. So 3 equations I have represented through by means of mathematics, right? So A is the coefficient matrix and x is the variable matrix and z is the value matrix, right? Okay, so everything I converted the equation totally into matrices. It's a 3 by 3 matrix, that is the coefficients, and x is a column matrix and z is also a column matrix. So I can solve this by using the standard row echelon form, right? So say how will you do? Right, first you construct the argument matrix. Argument matrix means take the A matrix and take the value matrix, value column, and augment it. Yes, I have augmented and do some multiplications, right? And addition operations over their rows and columns and make it to lower diagonal matrix or upper diagonal matrix. You will find one variable, right? So substitute it to another, you will find the values of x, y, and z. So I think you know this kind of mathematics from your elementary schooling level onwards, right? So I don't want to put too much of things over here, right? Okay. Next, I'm coming to rank of a matrix. See, the rank is something more important in data science, right? So a rank of a matrix is equal to the maximum number of linearly dependent row vectors in a matrix. So in a data set, if there are some redundant rows are there, that can be identified by using the concept of rank of a matrix because it gives the independence. So if you are going to form a data set to your problem, that should be all the rows should be independent in nature, right? Then only your problem. There should not be any kind of overfitting or underfitting problem. There is no need to go for regularization. But it is very, very, very difficult to have a matrix, right, with a proper rank, right? That's why some kind of a level of significance there in our research. Okay, fine. Next is coming to the concept of inverse of a matrix. Why the inverse are used? So if the very few numbers of variables and number of equations are there, that can be easily solved, right, by using Michelin form, right? But if there are more number of variables and more number of equations are there, then automatically the concept of inverse plays a very, very vital role, right? If you want to find the inverse of a matrix, then you have to know the concept of determinant, right? So how to do some determinant? It's very easy here, right? Say for example, I am going to show you how to find the determinant of a 2 by 2 matrix, right? So this is a formula, A into D minus C into B, right? This gives the determinant of a given matrix. It's a value. Okay. Similarly, I can find the determinants of 3 by 3 matrix, right? See, again, the same concept. The 3 by 3 matrix should be converted into 2 by 2 matrix. How? This is a basic principle. Say, for example, A into, so leave this particular column and this particular row. The remaining elements are E, F, H, I. So for that, you have to do some determinant. That is E, F, H, I. Similarly, for B, it is a standard formula, minus B. So if you leave this column and this row, D, F, G, I, yes. And similarly for C, C in 2. So leave this column and this row. You will find D, E, G, H. So now this 3 by 3 matrix is converted into 2 by 2 form. for calculating the determinant of B. Similarly, for 4 by 4 matrix, it can be possible by using 3 by 3. Again, solving this 3 by 3, 2 by 2 by 2, you can find the solution. So whatever may be the higher order, we are able to find the determinant of the matrix, right? Determinant plays a very, very vital in calculating the inverse of a matrix. Okay, before going to discuss about the inverse of the matrix, I have to know the concept called minor of a matrix, right? So how to find the minor of the matrix? Again, by taking the concept of what? Some kind of an operation. First of all, the matrix should be in square matrix form, right? See, deleting the ith row and the ith column will give the minor of a matrix of that element, right? Say, for example, here I want to find the minor corresponding to the element 1, 1. Let us consider. So I want to find the minor of the element 1. That is, I have to leave this column. I have to leave this row. So the remaining things are 2, 5, 0, 2. For that, I have to find the determinant value. That is 2 into 2, 4. Minus 0 into 5, 0. So answer is 4. So the minor of the element 1 of the matrix A is 4. Similarly, you have to find the minor of all the elements, right? By taking the concept of determinant, right? Why I am finding the minor? Because for finding the cofactor of a matrix, minor is something more important, right? How to find a cofactor of a matrix? Just changing the sign of the minor terms gives the cofactor. How to find the cofactor of a matrix? Just add the indices there. That is enough. See, for example, 1, 1. Say, for example, I want to find the cofactor of a matrix 1. So what is this position? It is first row, first column. 1 plus 1. 1 plus 1 is even number. If it is even, you have to put positive sign. If it is odd, you have to assign negative number. Say, for example, what is the position of the element 2 over here? It is first row, second column. Adding the index will give 1 plus 2. That is an answer 3. So it is an odd number. So I have to assign negative. So that is a logic of finding the cofactor of a matrix, right? So here, this is the cofactor of the matrix of A. Okay. Okay. Why I am going very fast here? Still, lot of concepts are there, right? For you. That's why I am going very fast. Next is adjoint matrix. How to find the adjoint matrix? Why I am doing all this operation? To find the inverse of a matrix. That is the thing. Right. So if I want to find the edge of matrix, okay, what you have to do, find the cofactor of a matrix. Yes, I already find the cofactor of the matrix. Here is my cofactor of a matrix A, right? Just to transpose the cofactor of the matrix. That's all for finding the edge of a matrix. See, I know this is my cofactor, right? Next, just transposing that cofactor, which leads to edge matrix, right? Once the edge is there, right, then it is very easy for me to calculate the inverse of a matrix. So I think you know the meaning of inverse. With respect to addition operation, if an element 2 is given, so if I'm going to do some addition with minus 2, it will lead to identity, right? If that is A star A equal to E, I am going to define everything in terms of groups, right? Here, sorry, A1 into A2 equal to E. Here, A1 is A2 is the inverse of A1, because by doing some operations, either it may be an addition, either it may be a multiplication. If it leads to an identity, then I will say that elements are inverse to each other, right? For addition operation, minus. For multiplication, it is division, right? I think you understand the concept of general inverse, right? So once if you know all these things, then it is very, very easy for you to find the inverse of a matrix. So if you want to find the inverse of the matrix, first what you have to do, you have to find the edge of the matrix, right? So once the edge is determined, what you have to do, you have to multiply the edge matrix by its inverse of determinant. It will give the inverse of the matrix. Once the inverse of the matrix is there, then you can do some good operation in data science. That's why I educated you all the various details related to how to find the inverse. Okay, so I will give this slide to you. It's self-explanatory, right? You can get a lot of things, right? So this is the way how I'm going to determine the value of x through inverse. See here, I will solve this problem, right? How to solve the simultaneous equation by using the concept of inverse. Say, for example, this is the equation given here, right? So this is A matrix, and variable matrix and value matrix. I want to find the value of x, y, and z, right? So this equation is represented by means of a representation a into x equal to z, where a is a matrix, coefficient matrix, x is the values, variables, that is z is the value, target value 1, 1, 4. Right now, what I am going to do, I am going to multiply a inverse by left hand side, and I know how to calculate a inverse. Just now we discussed. Yes, I multiplied both sides by a inverse. Now by taking some simple mathematics, right, grouping it, right? So a inverse into a x, that is just I am grouping. A inverse is that. I know pretty well that any matrix with its multiplication with inverse which leads to identity matrix. So see here, I now come across with x equal to a inverse into z. That's all simple. Once if you know the a inverse of any coefficient value, just multiplying it with the value, then you will know the corresponding variable values x, y, z. So this is the way in which I can solve any particular equation, any particular linear equation. Okay, now I am coming to this problem, how this inverse is used in data science. See, here I showed you a data set, right, which having several features, right? So now if you want to find or if you want to predict what would be the value of this particular attribute OOBP, right? Okay, I think okay, so through this particular inverse concept, I can calculate the parameter vector, right, by normal equation in linear equation. So far we have discussed how to find the inverse. By using the concept of inverse, I can do some regression analysis. So say let us, I construct the matrix value x. I am taking a subset of features, right? That is this matrix A, right? With this thing, I am going to calculate the value of OBP. That is, I am going to predict it. See, for example, it starts with 734. Yes, here 734, right? And this thing is 0259. Right. See, that means I am taking my matrix values RS, RA, W, OBP, SLG, BA. So these are all these values. I am going to take it as a matrix. Right. With this thing, I am going to predict the value of OOBP. That is possible through by means of inverse operation. That's all. To find the parameter vector theta, here theta is OOBP. Right. So just by doing this multiplication, x transpose multiplied by x, it is possible to find the corresponding prediction value theta, right, by using a linear regression formulation, right? So without knowing inverse operation, it's very, very difficult to know the parameter vector theta. Okay. Next, I am coming to the most important concept called eigenvalues and eigenvectors. I know how many of you people are here with eigenvalues and eigenvectors. I don't know, right? So it is very, very important for doing feature reduction operation in principal component analysis, right? I will show you some examples. What is eigen and what is eigenvector and eigenvalue, right? So it's already 60 minutes is over. Okay, I will come back to this eigenvalue and eigenvector later if I am having some time, because see, a lot of things are there. This is the way in which I prepared these slides, how mathematically you can find out eigenvalues and the eigenvector, and how this eigenvalue and eigenvector plays a very, very vital role in data science, right? Because I took too much of time in completing linear algebra, especially matrices and vectors, right? So I am skipping this concept because if time permits at last, surely I will cover this particular eigenvalues and eigenvectors. Okay, these are the way in which I can solve these problems. Right. Now I am coming to statistics, because the another topic that is given to me is statistics. I can say statistics, right, like this. There are three kinds of lies. For me, not for me, for Desiree. He can say it's a lies, damn lies, and statistics. So if you know how to lie with the data, that is all about statistics, right? Now come to the field of how to lie with some statistical procedure. Why study data statistics? Data are everywhere, similar to data science, right? So the statistical techniques are very much useful for making decision in our lives, right? Okay. So all statistics is about collecting, organizing, presenting, analyzing, and interpreting data. For what? For effective decision, I can say like that. Okay, so I don't want to waste my time in discussing with the importance of statistics. It's having a very vital application towards weather forecasting, because today here in Karaikal it is raining, right? So through some prediction, yesterday itself I came to know that today it's going to rain, right? How? Because of with the help of statistical data, right? I'm predicting all these things. Similarly, it's having a lot of application with respect to insurance industry, financial market, medical field, right? Even I can predict who is going to win the election, right? That is in assembly election. It's going to come in Tamil Nadu and Pondicherry, right? And 2021, right? If I have the proper data, right? Okay, fine. So what are all the things you have to know before going to learn the advanced level of statistics? You have to know certain things there. One is variable, right? And data. That is all about data set, right? A variable is a characteristics or attribute that can assume different variables. In computer science, we will say it is a feature, attribute like that. Okay, what is a data? The data are the measurement or observation that a variable can assume. So in computer science, we will say it's an attribute or feature which constitutes some values in a, that is called data. Okay, so variable whose values are determined by chance, that variables are called random variables. But in computer science, in data set, it's not a random variable. Okay, it's a specified variable. Okay, so that collection of data values, I can form it through by means of rows and columns, right? Through by means of matrix, I can say. But in computer science, we will call it as a data set. Okay, and each value in the data set is called data value or datum, right? Okay, you have to know all these fundamental things. Okay, so types of data statistics, right? There are two things out there: descriptive statistics and inferential statistics. If it is a descriptive statistics, I'm going to do some analysis to the entire population. That is called descriptive statistics, right? I'm going to take all the data and I'm going to do some kind of a conclusion, right? Okay, that is called all about descriptive statistics. Okay, what is the inferential statistics? From the population, I'm going to take some samples. From the samples, I'm going to do some analysis. With the result of the samples, I'm going to predict the population. Then that type of statistics is called inferential statistics. So always in computer science, inferential statistics are much more important than descriptive statistics. Okay, so I think this particular slide will clearly explain you what is a population and what is a sample, right? So it is very, very difficult to take all the data corresponding to populations because it's a lot of computation power. So that we are going for inferential statistics by taking some samples and generalizing certain things on these samples to the homogeneity, for homogeneity, right? Surely, probably it will give some good result. Okay, fine. See here, I'm giving some examples. So here I'm having some 5 rows and 6 columns, right? So I have to take all these 30 values, but it is not necessary. I'm going to take some randomness and I'm going to take alone 6 core information and I'm going to generalize for the entire population. This kind of thing is called inferential statistics. Okay, so this is another way, right? So for example, there are some group of peoples. They are ordered, they are clustered, but it's not necessary for me to get all these details. From each group, I can take 2 or 1 and I will go with some generalization. Again, this is an example of inferential statistics. That is on sample, I'm going to generalize the population, I can say like that. Okay. So there are different sampling. How to sample? That is a very, very important question. There are several types of sampling procedures are there. So for if you ask this for a social science students, the first question they will ask in the Viva voice is what type of sampling method you adapted, right? Whether it is a simple random sampling, stratified sampling, cluster sample, or systematic sample, right? So simple random sample, each sample has an equal chance of being selected. Yes. So in a population, any sample can be taken at any time, right? That is called simple random sampling. So in your research, you have to adapt simple random sampling. Stratified sample, the entire population is to be divided into groups, otherwise called as strata, and take a sample from each stratum. Then it is called stratified sampling. In cluster sampling, divide the population into strata, that is a cluster, and select randomly any particular strata. That is called cluster sampling. Okay. And systematic sample, right? Randomly select at any particular starting point and take every nth piece of data from the list of population, then it is called systematic sample. But in research, simple random sampling is highly accepted, right? With a significant level of error. Okay, so again comes the concept primary data and secondary data, right? When the data are collected specifically for the analysis desired, it is called primary data. But it's secondary data, the data are already collected by some research people. We are going to use it for our experimental purpose. Then it is called secondary data. In computer science field, all the research experiments and simulation works will be accepted only on benchmark data, that is on secondary data, right? Whenever the application is novel, then you can go for primary data. Okay, so while again I'm coming to the data set, right? In data set, ultimately we are going to have the features or attributes. In statistics, they will call it as a variables. That variable may be either qualitative or quantitative, right? So when a variable or attribute can be called it as a qualitative, the variables that can be placed into distinct categories, that is called qualitative. Say for example, gender is a qualitative, right? I can do it for male or female or other gender, right? What is a quantitative variable? A variable, right, that is numerical in nature, that can be ordered or ranked. That kind of variable is called as quantitative variable. Example, age is a numeric variable. Okay. So okay, I will give this slide for just for fun, because after 80 minutes of listening, whether you are listening actively or passively, I don't know. I take it you are listening to me. I lecture actively. I don't know how to do statistics, but don't worry. Why? But it does not matter, because I don't have data. If you don't have data, don't bother about statistics. If you really have data, then you have to bother about statistics here. Yes. Again, there is a lot of things out there in statistics here. I cannot compromise that statistics to be completed within an hour, 2 hours, or 3 hours. It takes its own time, right? So here I'm ready to give some inputs related to frequency distribution. It's a very, very important thing as a starting point in statistics here. Again, if time permits by the coordinator, I will come across with all these things. How to do some frequency distribution, right? Through on continuous data and categorical data, right? So this is the various steps I have to do for frequency distribution. This is an algorithm, right? And these are all the various pictorial way. I will come to this concept when the time permits. And how to draw histograms, how to draw frequency polygon, and how to draw or give, right? All these things. Okay. Now I am coming to probability, because this another concept is topic that is given to me. Again, I am going fast because of time limit, because I have to finish it within 90 minutes, right? Okay, probability. So it's a numerical measure here for measuring the likelihood of any event will occur, right? Usually the probability lies between 0 to 1. Everyone will know, right? So it will measure the when it is 0, there is no possibility of occurrence. When it is 1, surely there is a possibility of occurrence. If it is lies between 0 to 1, it will shows the uncertainty, the chance, right? So this particular diagram will explain you clearly the probability. It lies between 0 to 1. Yes. And at this thing, 0.5 is a mid-range. So the increasing the likelihood to occur. So if you move from 0.5, then automatically there is a chance of increasing the likelihood of the occurrence. So if it is 0, the event is very likely to occur. If it is 0.5, the occurrence of the event is just as likely as it is unlikely. If it is 1, it's going to occur. Right? Okay. In statistics, the experiment plays a very, very vital role. Right? But this experiment, right? In statistical experiment, probability determines the outcomes. Okay. Even though the experiment is repeated in exactly the same way, the outcome may differ. Say, for example, if I'm tossing a coin now, I can get head or tail. If I'm going to repeat the experiment for that time, I will get different things, right? The outcome may be different. That is that's why the experiment is called as random experiment. This experiment is completely different from the experiment that we are going to do it in a physics laboratory or chemist laboratory, right? So an experiment is any process that generates well-defined outcomes, right? I will give some examples. So the sample space for the experiment is a set of all experimental outcomes. Say, for example, while tossing a coin, what is the sample space? Head or tail. While tossing a die, what is the sample space? 1, 2, 3, 4, 5, 6. Similarly for deck of cards, or you can take any problem, right? So the outcome of an experiment is called as sample space. See here, tossing a coin, head and tail. Inspection apart, defective, non-defective. Conducting a sales call, purchase, no purchase. Rolling a dice and play a football game, win, loss, or tie. Okay, fine. So all the probability must lies between, if you are going to do some kind of an experiment, EI. So it should be lies from 0 to 1, right? Yes. And if it is, if I'm going to do some kind of assigning probabilities to experiment, that is probability of experiment 1, probability of experiment 2, up to n, I have to sum, again the value should be equal to 1. Sum of the probability of all experiment outcome must be equal to 1, right? Okay. So there are some addition law I already talked about in set theory. Probability of A union B equal to probability of A plus probability of B minus probability of A intersection. Why I am discussing all these things? Because in Bayes' theorem, if you are going to apply classification problem in machine learning, there comes Navy-Bayes algorithm, right? There, this addition law and multiplication law plays a very, very vital role. And mutually exclusive event. When the two events, right, are said to be mutually exclusive if the event has no sample points in common, right? That is disjoint. I already discussed in set theory, disjoint sets. Okay. So for example, event A and event B in sample space is completely different. There is no commonality. If there is no commonality, I already said the probability of A intersection B must be what? 0, right? Yes. And conditional probability, it is enough to define all these kind of things in data science. So without conditional probability, it's not possible for me to define Bayes' theorem, right? So that is probability of A by B, right? So such that if you want to find the probability of A given B, right? So that is answer is probability of A intersection B divided by probability of B. This is the conditional probability theorem. Similarly, multiplication law, P of A intersection B. That is P of B into P of A by B, right? This plays a very, very important role in defining the Bayes' theorem. Independent events, when the outcomes, one event does not affect the other event, right? Then we will say this, both the events are said to be independent in nature. P of, when it is independent, A and B, P of A by B is P of A. Similarly, if A and B are independent, P of B by A is P of B only. Okay. So with this logic, I can define multiplication law for independent events. P of A intersection B is P of A into P of B. Yes. Now I am coming to the concept called chi-square test for independence. It is very, very essential here. I think so far I have touched upon the basic mathematics. Now I am coming with some examples. So please, participants, please devote some kind of patient listening. Now I am going to explain you how to frame the hypothesis and how to test the hypothesis by taking an example. Okay. What does an hypothesis means? So it's a statement. It's a proposition. It may be either true or it may be a false, right? For what you are going to frame the hypothesis? For the variables in the data set only, you are going to frame the hypothesis. Finding the and finding the extendability for which only you are going to frame the hypothesis. If you are going to do any particular research, so without hypothesis, it is not possible for you to prove the experiment, right? Now, with the data set, I am going to frame some hypothesis. Usually in statistical theory or statistical thinking, they will say null hypothesis and alternate hypothesis. The null hypothesis is always framed by the name H0. And HA is always be represented by using alternate hypothesis. See, with this data set, see, I'm having a gender, the gender having the levels male and female. Similarly, the voting preferences, it is another feature. I can say with respect to computer science, with respect to statistical point of view, I can say two variables, I'm going to find the association, whether there is any relationship is exists between the variable Gender and voting preference. The gender has its two levels, male and female. Similarly, the variable voting preference having the levels Republican, Democrat, Independent. I think this data set with respect to US election. Right. Okay. Now I am defining my hypothesis. Gender and voting preferences are independent. That is, there is no association between gender and voting preferences. That is my H0. What is an alternate hypothesis? Gender and voting preferences are not independent. That means there is some association between gender and voting. That is my alternate hypothesis. Before going to do some statistical analysis, you have to think about significance level. What is significance level? Acceptance of error. I can say like that. If it is a scientific, again, I'm saying a very, very important thing here. The significance level should be of 1%, or it may be 5%, or it may be 10%. So usually in computer science, we will accept the significant level as 1% only, right? So 99% our result should be accurate. But in social science, you know, they will accept an error of 5%. That means they will take the accuracy of 95%. But in psychological research like that, you know, they will go with 10% of an error. Okay, that is the meaning of significance level. Okay, fine. Now mathematically I'm going to explain how to find association between these variables by using chi-square test. There are a lot of tests are there: t-test, f-test, ANOVA, right, SEM analysis. All these things are there, dear, but it is not possible to cover all these kind of things, right? Here I am going to explain how chi-square test is used for hypothesis testing, right? I have taken the sample data. This is the sample data you are seeing. First, you have to find the degree of freedom. Degree of freedom, that is very, very essential, right? See here, degree of freedom means number of rows minus 1 into number of column minus 1. That is G rows, V columns. How many rows are here having? Male and female levels. So G is 2 minus 1 into V minus 1. How many column? That is the other variable. 3 levels. 3 minus 1. 2 minus 1. 1 into 2. 2. Yes, now you are able to find out how to calculate the degree of freedom of when a given data set is given. Next, you have to find out expected frequency count. The formula for expected frequency count is Ng into Nv into N. We know N, right? Okay. See here. I have to find out the respective, how many males with respect to Republican, how many males, because it's a frequency count, right? How many males related to Democrat, how many males related to Independent, like that. So you see here, if you just see the observation, I will explain it for one row. Expected frequency count of male with respect to Republican. So what is Ng? Ng is 400, total male, into 450. What is the total Republican? 450, divided by total value 1000. This is the expected frequency count of male with respect to Republican level, Republican. I am getting the answer 180. Similarly, I have to do it for all these things, right? Male, Republican, male, Democrat, male, Independent. Similarly, female with respect to Republican, Democrat, and Independent. So I am able to find out the expected frequency count. Okay, then you straight away you can apply the whatever may be the calculated values to chi-square test statistics. This is my formula for chi-square statistics. That is, what is an observed value minus expected value divided by expected value. What is my observed value? So male, it is 200 minus, right? What is my expected value? In the previous thing, I have expected 180. Okay, it is 200 minus 180 the whole square divided by expected value 180 plus, because it's summation. Similarly for male, for Democrat, 150 minus, what is my expected value that I calculated? 180. So 150 minus 180 the whole square divided by expected values. Similarly, I have to do it for everything. So after doing all this computation, I came with the value 16.2. That is my expected value, right? Now, if you want to find whether the hypothesis to be tested positive or negative, that is true or false, you have to calculate with a tabular value with the expected value. In the website, there are several calculators are there. Once if you know this calculated value, calculated chi-square value 16.2, and if you know the degree of freedom 2, then give it to that calculator, it will give this value. So I have given this value, the expected value 16.2 to the chi-square calculator, and I am able to get the significant level, which is 0.003. That 0.003 is less than my significant level that I have chosen earlier, right? That is 0.05. So I am rejecting my null hypothesis. That is H0. That is gender and voting preference are independent. That hypothesis I am rejecting. That means there is some association between the gender and the voting preferences. So this is the way in which you can check the association between the variables, right? Okay, so this is the way in which I can test any hypothesis, right? If the more number of levels are there, then you have to go for more than 2. You have to go for F test, P test, ANOVA, MANOVA, like that there. Okay, so due to time constraint, I restricted my presentation to only chi-square test. Okay, so after all this mathematics, without giving some real-time example with respect to data science, it's meaningless. I think 5 minutes time is there. Now I am going to explain you how I am going to use the vector, how I am going to use the knowledge of matrices in performing text analytics there. I think some resource person is going to engage you related to NLP. So during that time, you will get all these kind of mathematics. Now I am going to explain you within 5 minutes how to do some text analytics, right? Okay, I am taking the unstructured raw text. Okay, sorry. Okay, raw text. Then what I am going to do, I am going to do some NLP operation. Stemming means finding the root word. Stop word means removing the unnecessary words from the raw text. Once if it is done, then I will get some sequence of tokens. I am going to break it, right? I am going to tokenize the entire text, running text into token. Okay. Then what I am going to do, I am going to add weights similar to that of neural networks. For each feature which is extracted, you will assign some weight, likewise. Here I am converting all the unstructured information to structured one by assigning weights. Right. Once the weights are assigned to the words, it becomes structure. It becomes numerical value. If I'm going to organize that numerical values, yes, I will do it in terms of matrices. Right. Okay. I will give some example. Right. Then that once the matrix is there, I can do wonders. Okay. So the matrix, all the rows, I'm going to call it as a vector. Right. Once if I represent each row as a vector, then I will do several functionalities like I can do document similarity, or I can go for document classification by using the standard classification algorithms like decision tree, Navy Bayes, support vector machine, random forest, XGBoost, right? Or I can apply not CNN, I can apply RNN, recurrent neural network, because the data is sequence data. If the data is a sequence in nature, I have to go for RNN. If it is an image data, then I have to go for CNN. For generally, I am saying all these comments. Right. Let us see what I am going to do. This is the text I am going to take. Right. Yes, text. It's an unstructured text. What I am going to do, I am going to convert all this unstructured information to structured. Structured means what? Some numerical value how I am going to assign. Right. That representation is called bag of words representation. I think tomorrow or today or tomorrow you will come across with all these things in the heading of NLP. Right. Okay. Now I told that I taught you the concept called vector. Now by using the concept cosine similarity, I can find the relationship between one document to another document. So this is the cosine similarity formula. A dot B divided by modulus of AB, where A and B are the vectors, and this is the corresponding formula for cosine similarity. So after doing this, after computing this value, I am going to check whether the data points are parallel. If the data points are parallel among the two vectors, then you can say these two documents are equal. If it is orthogonal, that means there is some deviation is there with respect to an angle, then I can say this document is dissimilar to that document with respect to some degree of independence. Don't worry, dear, I am going to give an example for that, so that now you clearly understand the text analytics principle. See here, for simplicity, I can I have framed the entire thing in a single slide. See here, I have taken 3 documents. Yes, document 1, document 2, sorry. Document 1, document 2, and document 3. So I am doing all the NLP operation, stemming, root word removal, all these things. So I come across with the words course, data, interest, mind, study, subfield, text. Okay, now I'm not going to assign weights. I'm just going to check whether the course, the word token course is there in document. Is it there? Yes, it is there. So I put 1. So whether I am going to check whether the word data is there in document 1. Yes, it is there, 1. So in this way, I'm going to fill this particular matrix. Now see how the words are converted into values, right? This kind of matrix is called term document matrix. Otherwise, they will say document term matrix. Once the document term matrix is there, each document represents a vector, right? Now, if I want to find out whether there is any similarity is there between document 1 to document 2, just apply these 2 vector over here in similarity ratio, right? You will get some value, right? And you plot it in any 3-dimensional space, you will get some vectors like this. Now, just measuring the angle will give you how one document is different from other document there. So that's all about cosine similarity. And in my clock, the time is exactly 11:30. So I covered most probably all these things, right? But I have not covered frequency distribution because of time constraint. Because some other speaker is also there. That's why I restricted, right? That's all there. So I am very much eager to cover the concepts like frequency distribution and eigenvalues and eigenvector. Okay. Now,
yes, sir. No problem. No problem. We'll share the slides so that.
Okay, sir. Okay, now I am stop presenting my presentation. Stop sharing.
Yes, sir. Yeah, sir. Now it is a question and answers.
Yes.
You people can raise your hand or post your question in the question.
Thank you, Jai Shankar and Shamira Banu. You said, sir, store all PPT in Google Drive. Okay, dear. This presentation is not for me. For you only I prepared. Right. So I think it's very difficult for you people to ask questions because I talked everything through mathematics, right? Okay. Yes, you please proceed here by asking question, right?
Yes. Anybody want to ask questions? You can
Mathematical foundation is necessary to data science. Yes, exactly. Honestly, this is a powerful presentation. Thank you, David. Thank you very much. So apart from thank you, you please ask me some questions. I'm very much delighted.
Can I, sir?
Okay, sir.
Can I?
Yeah, you can.
I'm audible to you?
Yes, sir.
There are 2 questions for me.
Yes.
One is on eigenvalues and eigenvectors.
Yes.
So how can I use, if possible, can you show it?
Okay.
Otherwise, you can explain.
Okay.
Can I ask the second question also, sir?
Yes, sir. Please go ahead, sir. Go ahead.
Yeah.
I'm having a wonderful primary memory.
Yeah, in chi-square test, according to my knowledge,
yes.
Data used for the small sample.
Yes.
But when coming to the data science, we are taking very large sample.
Yes.
How this will be correlated?
Again, I'm saying data is not at all important here because I'm going to take only the future variables. Data is immaterial for me because computation power is there for me. You have to understand when you have to apply chi-square test. Say if you want to find the association between 2 variables, then only you have to apply for chi-square test. The number of rows of record doesn't matter there. Number of features only plays a very, very vital role. Okay. Next, I'm coming to eigenvalue and eigenvector, right? So for dimensionality reduction only, we have to know the eigenvalue and eigenvector. You can reduce the features. Say, for example, for any particular problem, I'm having some 1,000 features are there, right? By taking all these 1,000 features, doing this computation, it's very expensive. But anyhow, even if you are having the power, redundancy will be there. It will lead to some error. So removing the redundancy, we are going for eigenvalues and eigenvectors, right? So that is a concept that I have not covered. Surely, if some time is given to you, I will share my presentation to you, right? How especially, right, eigenvalues and eigenvectors are used, right, in principal component analysis. I'm again saying, so we are going to use eigenvalues and eigenvectors in PCA only, right? Not to any particular machine learning, right? If you are having enormous data and if you want to find out the importance where the actual knowledge is there, then you can, then surely the eigenvalue and eigenvector will give you the right direction.
Thank you, sir, for giving answer to my questions.
Okay,
And I thank you for covering all the set theory. 90% of the definitions are covered, I think, to my knowledge. Thank you, sir. Thank you.
Thank you, dear. Thank you.
Next,
so still, I have covered only little bit of probability, little bit of statistics, dear. Don't come to a conclusion that you people have learned statistics, linear algebra, probability like that, right? It is an ocean, right? It is an ocean. I can talk about statistics for 10 days continuously. It's my pleasure.
Okay, sir. Next, Samiran, you can ask. Samiran, please, you can unmute and ask. Samiran, are you there?
What is the importance of eigenvectors? Again, I am saying, dear, see, whenever there are 100 features are there, it is not necessary to look for 100 features. You can restrict. If there is some redundancy is there, once if you know the eigenvalue, and for the respective eigenvalues, if you are able to know the eigenvectors, then it shows these are all the features that can be removed. Okay, that is the purpose of finding eigenvectors. Eigenvectors can be found out for each eigenvalue. Again, I am saying I have to find out through some characteristics equation only. Okay, dear? Okay. If you give me another 30 minutes of time, I will explain how to find out eigenvalue, eigenvector with respect to any particular mathematically as well as with respect to PCA also.
Sir, one more question. Can we calculate correlation between two non-numeric variables?
No, dear. See, dear, there are variables. Always you have to convert the categorical variable to continuous. Do you understand? Then only you have to do all these things, right? With the categorical thing, it's not possible. Okay. What is the best method for data pre-processing in STAT? See, there are a lot of normalization techniques are available there, right? Say, for example, when the noise is there, when the error is there, right? Say, normalization comes into picture. There is Z-score normalization is there, min-max normalization is there, right? By using some binning method, you can fill the data. We can do all this pre-processing. Pre-processing is necessary whenever there is a noise or error is there in the data while capturing, right? That can be done. A number of techniques are there.
Next one, sir. Which method is suitable for weather forecasting?
Say again, which method you have to explore here? That is a beauty of machine learning. Yes, model. I cannot. So, what type of data you are going to have? That plays a vital role, right? On which data set you are going to work? You just experiment it, all the benchmarked algorithms, right? And you can report it to the research community, right? When will they accept? If you work on the benchmark data set, then only they will accept. If you are going to work on with your own primary data, I think the research community will not accept. Okay, First of all, release your data set. First of all, release your data set with proving all these mathematics, right?
Sir, we have next session at 12 o'clock.
Okay, sir. Okay. I think I served my business. Kumar, yes, sir. Kumar is there. Kumar,
yes, sir. Yes. I am only speaking.
So you the Kumar.
Yeah.
Sir, I am not seeing you, but anyhow, thank you for this invitation, sir. I don't know whether I have served the business, right? But thank you. Thank you for
you did a good job.
Thank you, sir.
Okay, sir.
Surely I will share all my PPTs, everything to you, sir.
Yes, sir. Share me. Okay, next, invite.
Thank you.
Shabina.
Sir, can I leave, sir? Sir, can I leave?
Sir. Wait, sir. Next, I invite Shabina, research scholar, to deliver the vote of thanks.
Hello,
Madam,
am
please.
I audible, sir?
Yeah, audible.
Yes, very good morning to all. Myself, research scholars from Department of Computer Science, Central University, Kerala. and my research area is in audiovisual speech recognition system. And first of all, my thanks to Kumar sir for giving me a chance to propose vote of thanks. Okay, today we have an eminent speaker, Dr. Kumaravelan sir, from assistant professor from Pondicherry University. It was a very wonderful and informative session on the topic of mathematical foundation for data science. I think sir here clearly explained about the set theory, functions, linear algebra, metrics, and statistics. And your time organization is very excellent, sir, because within this limited time, you covered a very vast session, very nice manner, sir.
Thank you.
I think all participants benefited from this session, and
Thank you.
because they all are actively participated in question answering section. So on behalf of this computer science department, Central University of Kerala, I express my sincere thanks to Dr. Kumaravelan sir. And in future also, we are expecting more from we need your help and support. Thank you, sir. Thank you for coming here. And special thanks to our dear participants for actively participating in this event. Thank you. Thank you all.
Okay, bye-bye, sir.
Thank you for your vote of thanks.
So,
sir, thank you very much, sir,
okay,
for your
so before that, the vote of thanks by Shabina, So, Shabina, if you are working in a speech recognition, I think you can think about some stochastic model, right?
Yes,
so, related to reinforcement learning, there are a lot of research works are there, right, for speech recognition. So, you can think about MDP, PO-MDP, right? These are all the various statistical models are there, right? So, you can compare your research work. Thank you. So, thank you, sir.
Okay, sir. Thank you. Thank you very much, sir. Thank you.
May I?
So, can I leave?
Just a minute, sir. Somebody is speaking. I can. Yes.
Hello. This is Bhagyashri, sir. Sir, actually, I'm from electrical field, and I'm interested in AI, and but in the programming side here, the mathematical modeling, I understood everything. But the last you explained the
chi-square test.
Yeah. I didn't understand that thing. So I have humble request that if I have your email ID or contact details, so that I can contact you if I get any problem regarding.
No, you can get my details from my website, Pondicherry University, campus. Myself, Kumaravelan, and my email ID is gkumaravelan@gmail.com. Right? So you can, under any circumstances, you can call me and I can clarify your doubts if I am able to clarify that. Okay. Otherwise, I will find out the gaps and I will fulfill the requirement. Thank you.
Thank you very much, sir.
Thank you.
Okay, sir.
Thank you,
very
Kumar,
much, sir.
Thank you,
sir. Thank you very much.
Okay. I am leaving, sir.
Okay, sir. Good. Participants, still anybody not given attendance, please give it. Again, I am posting the link. So next session will start by 12 o'clock. Okay. All of you get back by 11:55 a.m. All of you join by 11:55 a.m. Thank you.